Hi, my name is Justina Sanchez and I'm a product safety engineer. You may be thinking, what is that and what do you do? Well, I'm here today to let you know. A product safety engineer does the testing and certification of products before they go to market. So if a manufacturer has something they want to sell, we make sure that it's safe for you as the consumer to use. So come with me and I'll show you some of the tests we perform. This is our wet room. What we do here are different types of environmental tests. What I'm going to show you today is our rain test fixture. This is used for products that are going to be mounted in the outdoor environments that would regularly be exposed to rain. So come with me. This is our mock sample here, and what we would do is we would put it under the rain test fixture. In its first position, we're going to let it sit there. It's going to sit there for about 2.5 minutes, and then we're going to rotate it at every angle, making sure that the rain evenly hits all parts of the sample. Then we would open it up and diagnose it, see if there was any rain that got inside that could potentially harm the safety aspects of the enclosure. So depending on where in the world the product is going to be used, it could potentially be exposed to extreme environmental conditions, meaning high heat or really low temperatures or even really dusty environments. In those situations, we will carry out the tests that are applicable, one of them being a dust test. So come with me and I'll show you our dust chamber here. So this is our dust chamber. Any products that are going to undergo dust testing require that we wear personal protective equipment so that we, as the tester, are safe from the talcum powder that's within the chamber. This is a special certified talcum powder required to use for this test. So this is our test sample, and what we're going to do is set the sample in here. We'll connect it to a vacuum tube, and then we're going to let the dust circulate around the sample for 2 to 8 hours depending on how large our sample is. Upon completion of the test, we're going to open up our sample and evaluate if any dust got inside that could potentially cause a hazard, meaning short components or cause a corrosion or erosion of some of those electrical components had dust got inside of there. Another common test we perform is called flame testing. When parts of a product don't have the proper flammability ratings, we have the ability to give them that. The reason that's important is if a fire were to break out inside of that product, we need to make sure that the fire is not going to spread and become an even bigger problem than it was. So having the proper flammability ratings on the plastics, the wiring boards, and that kind of thing is really important. So this is how you perform the test. Down here we've got our propane. We're going to turn this on. We've got our needle flame tester here. So we're going to turn this on. And now we've got to measure the size of the flame because every test we perform is done to a certain standard, and there are certain requirements for every single part of the test that need to be met. And our standards are what tell us that. So there we are. Then we're going to take this and we're going to hold it right up to here. So depending on which standard we're using, we'll let it go for 30 seconds or a minute, and then we want to make sure that it'll extinguish itself, or if it burns, for how long after the flame is removed. So all of these things are going to factor in into deciding if this is a pass or fail. The last test I'm going to show you is called capacitance discharge, and what that does is we measure the time that it takes for the energy to dissipate from the time a sample is turned off. And the reason it's important is because if you were to unplug something from the wall or from an electrical socket and you go to touch the prongs, we want to make sure that you're not going to get shocked. So here what we do is we've got it set up and we're going to shut off the power to the unit and then capture the wave so that we can measure how fast it took for that voltage to leave. So here we're going to shut it off and then we're going to capture that. So if you see here, we can see our peak and we can see the time that it took for the energy to leave. So based upon these results, we're going to determine our pass-fail criteria. Thank you for letting me show you some of the tests that we perform. I hope you have a better understanding of what a product safety engineer is and what it is we do.